Hey everyone, welcome. I am absolutely thrilled you're joining me for this explainer. Look, let's jump right in. Every single time you click a link, hit enter on your keyboard, or tap an app on your phone, you are activating a truly staggering, complex ecosystem. It's a digital world filled with brilliant engineering that connects us across the globe in a matter of milliseconds. But alongside all that brilliant engineering, there are hidden traps. Today, we're going to explore the fascinating duality of the web. We're looking at how the very technologies that build our digital world can also, unfortunately, be weaponized against us.
I really want you to think about this for a second. We all trust our browsers, our apps, and our favorite websites every single day. But do you actually know the hidden risks lurking directly in the code you're interacting with? The modern web isn't just static text anymore, right? It is a highly interactive, dynamic machine. And wherever there is a moving part, well, there's a potential vulnerability. Our goal today is to pull back the curtain on those exact vulnerabilities so you can navigate the web with your eyes wide open.
So, here is our roadmap for today. We'll start with a quick welcome to web tech, move on to the front-end foundation, navigate the network, look at browsers and servers, and finally, weigh the cybersecurity trade-off. Simple enough? Let's go. To start, let's establish a baseline. What exactly is web technology? Well, by definition, it's the collection of standards, languages, protocols, tools, and software used to create, deliver, and interact with resources on the World Wide Web. It's the whole shebang. We're not just talking about static pages anymore. This is the engine behind massive cloud dashboards, your favorite streaming platforms, and secure digital payments.
All right, section one, the front-end foundation. This is all about building the visible web.
Think of HTML as the structural frame of a house. It organizes web content using basic elements like headings, paragraphs, and forms. It's absolutely essential. But look closely at the risk here. If those forms, like a standard login box or a search bar, are poorly validated, they basically become the perfect entry points for injection attacks. If the HTML form doesn't strictly check what you're typing, a digital burglar can just inject malicious commands straight through the front door. Next up, we've got CSS. If HTML is the frame, CSS is the paint and the interior design. It controls the presentation, the layout, the colors, the fonts. But here is a truly fascinating twist. Even mirror presentation code carries a security risk. CSS can sometimes be manipulated to leak sensitive information through what are called browser-side channels. Literally, even the paint job can betray secrets to a clever attacker. And then there's JavaScript. This is the electricity that brings the whole house to life. It adds client-side logic, event handling, data validation, and all that rich interactivity we love. But as we know, electricity is dangerous if it's not wired right. Unsafe handling of JavaScript creates major vulnerabilities, specifically something called cross-site scripting, or XSS for short. If an application accidentally allows untrusted content to be executed as a script, attackers can hijack that power to steal your session tokens, modify what's on the page, or just siphon off your private data. Moving right along to section 2, navigating the network. This is how we actually connect you to the data. Okay, everything starts with an address, the URL. We use them literally dozens of times a day, but let's break one down. First, you have the scheme, like HTTP or HTTPS. Then the host, say example.com. Next is the port, which is a logical endpoint. Then comes the path, pointing to the specific resource you want. You might also see a query string for extra parameters, and finally a fragment to jump to a specific section on the page. Understanding these specific pieces is vital, because this is exactly what attackers manipulate. The utility of a URL is just incredible. It pinpoints a single resource anywhere on the globe, but attackers know this, and they heavily rely on misleading addresses. They use confusing or lookalike domains, for example, spelling example.com with a number 1 instead of an L. This right here is the foundation of phishing and typo squatting. Oh, and a quick pro tip straight from our sources, sensitive information should never, ever be placed in the URL's query string. Why? Because URLs are often routinely logged by servers and browsers, leaving your secrets completely exposed. Once we've got the address, we need a protocol to actually talk. HTTP and HTTPS. Now, HTTPS uses encryption to protect your data in transit, but crucially, and a lot of people misunderstand this, HTTPS does not prove a website is trustworthy. It just means your connection to the bad guy is securely encrypted. Furthermore, HTTP is stateless. It forgets you immediately. So to remember that you're logged in, applications hand out session cookies. If those cookies aren't protected with proper flags, attackers can steal them and completely impersonate you. They won't even need your password. Okay, let's jump into Section 3, browsers and web servers. This is the request and response cycle. When you type a URL like example.edu/login and hit enter, this amazing rapid-fire sequence kicks off in literally milliseconds. First, the browser checks the URL and queries the DNS to find the IP address. Second, it opens a network connection to the server. Third, it negotiates that secure TLS encryption we just talked about. Fourth, it sends an HTTP request like get/login. Fifth, the server processes this and fires back a response, including a status code, headers, and the HTML content. And finally, the browser renders the HTML, paints it with CSS, and executes the permitted JavaScript. It's really a beautifully choreographed dance.
So your browser is basically acting as your personal bodyguard here. It enforces sandboxing, checks policies, and verifies certificates. However, the browser is essentially blindly obedient. If it gets tricked into trusting bad code, like letting a digital Trojan horse through the gates, it's going to execute it. The bodyguard only works if it knows exactly who the bad guys are. On the flip side of that connection is the web server. Its job is vital. It stores and serves those web resources, or it forwards your request to the application's backend code. But listen, a web server is only as safe as its setup. The massive danger here is misconfiguration. A lazy or accidental misconfiguration can literally leave the digital backdoor wide open, exposing private files, hidden admin panels, or even running outdated, vulnerable software.
And behind that web server lies the deepest vault of all, the databases and APIs. This is where the true value lives: your user records, application data, core functions. It is incredibly useful, but that makes it the ultimate target for attackers. If access controls are weak down here, or if those injection flaws we mentioned back in the HTML slide pierce all the way through, game over. An attacker can compromise, steal, or delete entire stores of data. Which brings us to Section 4, the cybersecurity trade-off. It's all about balancing function and security.
Let's bring it all together. Every single component we've just discussed has a brilliant intended role, but it's paired with a specific vulnerability. HTML structures content, sure, but risks injection. JavaScript adds interactivity, but risks cross-site scripting. URLs locate resources, but enable phishing. Web servers serve resources, but misconfigurations expose data. You simply cannot have the incredible utility of the web without accepting and actively mitigating these built-in risks.
But here is the absolutely crucial takeaway. None of this tech exists in a vacuum. Cyberspace is a socio-technical system. What that means is the technical components, the servers, the protocols, the code, they cannot be separated from human behavior, organizations, and policies. Think about it. A phishing attack might use email infrastructure and lookalike URLs, but it ultimately succeeds because a human user was persuaded to click a malicious link. Secure design is totally useless if administrators and everyday users don't follow safe practices. And that leads to a massive, harsh asymmetry on the web. Our sources put it perfectly. Attackers often need to find one weak point, while defenders must protect many assets, users, and processes continuously. Software automation allows defenders to monitor networks, yeah, but it also allows attackers to automate scanning and phishing at an unbelievable scale. The defenders literally have to be perfect everywhere. The burglars just need to find one open window.
We've seen how the exact same technologies that empower us can also provide the blueprints for attacks. The web is fundamentally built for connection, but those connections inherently carry hidden risks. So I want to leave you with this final provocative thought to reflect on. Knowing how all this works now, from the HTML on your screen to the servers halfway across the world, are your daily digital habits helping the defenders, or are you accidentally leaving the window open for the burglars? Stay curious, stay vigilant, and thank you so much for joining me for this explainer.